Hello everyone, a very good morning to all of you. Right? So in yesterday's session, we already discussed about few definitions of SI units. What are those SI units? First one, meter. Next one, kilogram. Next one, second. Okay? What is the definition of meter? It is the length of the path covered by a light with speed of 3 into 10 raised to 8 meter per second in 1 by some fraction. Even I have not remembered that value because of it is too lengthy. That much part of time interval. Okay? Right, means roughly I will tell you 1 by 3 into 10 raised to 8 time interval of time interval of that particular period in which whatever the distance covered by the light is treated as 1 meter. The next one is 1 kilogram. 1 kilogram simple definition, mass of cylinder made of platinum and iridium. Right? The next one is second. How to define second? It is a little bit complicated. Yesterday we discussed. Right? In cesium atom, okay, some 9 millions of transitions between, roughly I am telling you because of that value is also very difficult to remember. So such a number of transition between two hyperfine levels with the emission of radiation, right, is treated as 1 second. Okay, so these three SI units we are thoroughly discussing in PUC first year. And the next one is Kelvin. What is Kelvin? Actually, Kelvin is a SI unit of thermodynamic temperature. Am I right? Okay, right. Now I want to define Kelvin. Already in your lower standard, how to measure temperature? What are the units of temperature? Do you remember? Human body temperature we are expressing in terms of degree Fahrenheit. Okay. In our lower standard books they mentioned that room temperature 27 degrees Celsius. 27 degrees Celsius. Right? So in generally we are representing, in most of the cases we are representing temperature in terms of degrees Celsius. That is not SI system, that is a CGS system. The SI unit of temperature is Kelvin. Okay? So here I will write like this. Do you remember in some textbooks they will give like this: 27 degrees Celsius is equal to 300 Kelvin. 27 degrees Celsius, it is in terms of degrees Celsius. In terms of Kelvin, room temperature is how much? 300. So, how to convert this degrees Celsius into Kelvin? Yes, there is one formula. We will discuss in thermal properties of matter. Only for a definition of defining of this Kelvin, I wrote this sentence. Okay, I will write, see, 27, if it is added with 273, 27, if it is added with 273, you will get how much? 300. Clear? So, if you convert degrees Celsius into Kelvin, we should add 273 to this 27, then you will get the temperature in terms of Kelvin. So now I will write a standard conversion. See, temperature in Kelvin. I want temperature in Kelvin if temperature is given in degrees Celsius. Actually this is not 273, it is not actually 273, exact value is 273.15 plus C. C andre sir, what is C sir? C andre, C actually, it is the temperature value in Celsius. For example, C is equal to 0 degrees Celsius. 0 degree Celsius. 273.15. Okay. Here temperature is 27 degrees Celsius is given. Here C is given as 27 degrees Celsius. 27 plus 273, nearly you will get 300 Kelvin. Okay, you forgot about this conversion. We will discuss in detail this conversion, one temperature scale into other temperature scale. We will discuss in thermal properties of matter. That is the second part of the PUC first syllabus. Okay? Right. Then here I will write like this. See. 0 degree Celsius, 0 degree, put C is equal to 0 degrees Celsius is equal to, you will get how much? 273.15 Kelvin. Am I right? Correct? Okay, fine. According to this relation. Okay? Right. 0 degrees Celsius is equal to 273. 27 degrees Celsius is equal to 300.15. Yes, you just remember this conversion. You don't think behind this. It is not necessary also in this units and measurement. Okay? Right. Right. Okay, listen carefully. Then how to define Kelvin, sir? How to define Kelvin? Actually, the International Bureau of Weights and Measure, to define this Kelvin, they are considered triple point of water. What is the triple point of water? Triple point of water. Triple point of water. Right? Listen carefully. Don't confuse. Triple point means 3 points. What is the meaning of triple point? Listen carefully. This concept also we will discuss in thermal properties of matter. Wait. Up to that wait with more patience. Okay? Don't ask more questions related to this word. Right? Just I will explain what is meant by triple point. Triple point of water is the temperature or it is the point at which water, ice, steam, all the 3 states of matter coexist in equilibrium. Once again I am repeating, triple point of water is the point at which 3 states of matter, that is 3 states, one is ice, one is liquid water and another one is steam. All these 3 coexist in that point. That point is taken as triple point. Only this much you will remember, that is enough in this chapter. Okay? So that point is taken as a reference to define this 1 Kelvin. Okay, sir, at what temperature this triple point of water exists? Means at what temperature that matter is in the form of water, ice and steam. Means these 3 states coexist at that point. So that triple point of water temperature is 0.01 degrees Celsius. At this temperature, right? Ice, water, steam, all these 3 coexist in equilibrium. That point is known as a triple point. Corresponding to that triple point, the corresponding temperature of the triple point of water is 0.01 degrees Celsius. Now it is converted into Kelvin. Now here 273.15 plus 0.01. How much? 5 plus 1, 6, 1, 273. It is equal to 273.16 Kelvin. Okay? Up to this, if you understand, it is well and good. Right? Now listen carefully. From this I will write like this. 1 Kelvin, I want to define 1 Kelvin. I want to define 1 Kelvin. 1 Kelvin is equal to, I will write like this. 1 upon, mathematicians, 2 under 2 into 1. Am I right? 2 meters under 2 into 1 meter. Correct? Okay. 273.16 Kelvin means 273.16 into 1 Kelvin. Correct only. Now I am writing 1 Kelvin. 1 Kelvin is equal to, this is taken this side, denominator. Okay. 273.16 of what? This one. Of what? This thing, right? This is what? Fraction of triple point of temperature, triple point of water temperature or triple point of temperature is taken as 1 Kelvin. ಏನು ಅರ್ಥ ಆಗಿಲ್ಲ? ಅರ್ಥ ಐತೆ? No? Listen carefully. Sir, you forgot about this. Even if you are not remember this also, we don't bother about that. Right? To define 1 Kelvin, they are taking as triple point of water temperature as a reference. At this temperature, we are defining triple point of water. This temperature, if you convert into Kelvin, you will get 273.16 by using this formula. Okay? From this I am writing 1 Kelvin. 1 Kelvin is equal to 1 upon 273.16 of what is this? What is this? This is water. Triple point water temperature. So that is what definition of 1 Kelvin. Okay? Now I hope it is clear. Right? Now I will write definition of Kelvin. Please write down. Here I will write definition of Kelvin. Kelvin definition. It is the fraction. Correct? Correct? Mean mathematics 1 upon something, nothing but that is a fraction only. Okay. It is the fraction. 1 upon 273.16 of the thermodynamic temperature of the triple point of water. Okay? It is the 1 Kelvin is the fraction of 1 by 273.16, okay, of triple point of water, temperature of triple point of water. This much if you remember, that is well and good. In first chapter. Later in upcoming chapters in thermal properties of matter, we will discuss in detail. So don't ask any doubts beyond this. Clear? Right. So next one, listen carefully. Next one, mole. Right? Actually, these two SI units we will discuss in heat and thermodynamics. And in chemistry, everywhere we are using this mole SI unit. In physics also, in heat and thermodynamics, we use these two SI units. Clear? Right. Then what is mean by mole? I think you already studied in chemistry also. What is mean by mole? Tell me. It is the amount of substance. right? Amount of substance contain so many entities of 12 grams of carbon isotope atom is known as 1 mole. Not understood. Correct? Listen. Actually, it is a SI unit of what? It is the SI unit of amount of substance. It is a SI unit of amount of substance. Right? Correct? This substance contains so many entities. Sir, entities means what, sir? Atoms, molecules, ions. Understood? Atoms, molecules, ions in 12 grams or 0.012 kg of carbon isotope. Sir, just now only you told 12 grams. Now you are telling that 0. I am converting grams into kilograms. Okay? So 12 grams of carbon isotope are 0.012 kg of carbon isotope. Okay, so that is what the definition of mole. Okay, you already studied in chemistry. Now this is enough. In units and measurement, this much information is enough. We don't want to behind this. But you know very well, right? 1 mole contains Avogadro number of atoms or molecule. That is what? 6 into 10 raised to 23. What is this? This is nothing but Avogadro number. Okay? Right. And then now I will write the definition of mole. So it is the amount of substance which contains many entities as there are atoms in 0.012 kg of carbon isotope. Okay, so this is about definition of mole. Clear? Right. So next one is ampere. It is a SI unit of electric current. Am I right? SI unit of electric current. You already studied in your 10th standard. How to define 1 ampere? See, to define 1 ampere, right? Consider two thin conductors. Right? Consider two thin conductors of negligible area of cross section. Separated by 1 meter. And both the thin conductors carrying I current. Now my question is, and your question is, when this current is said to be ampere. Am I right? Okay, sir, how to provide current? Just you connected it to some external battery. Okay, you forget about that. Now two thin conductors of negligible cross section, parallel, and which are parallel to each other, not perpendicular to each other, separated by 1 meter distance. They are apart by 1 meter distance, right? Both are carrying the same current. When both the conductors carrying the current I, there will be a produce of force between the two conductors. Okay? Now again I am increasing the current. Okay? The force between the two conductors also changing. Right? But when that force, see, between these two, when current is passing through these two thin conductors, there is a force between the two conductors. Now again I am changing the current through both the conductors. Clear? Again I am changing. But at one particular value of I, if the force between these two conductors, if it is equal to 2 into 10 raised to minus 7 Newton per meter length of these two conducting wires or conductors, then under this value, whatever the current is flowing through these two thin parallel straight conductors are said to be 1 ampere. No, you are not following. Listen. Two thin parallel conductors placed at a distance of 1 meter. Okay? Next, both thin conductors carrying the current I. Okay? When I current carried by these two conductors, there would be a force. Okay? Right? This I is equal to 1 ampere when this force must be equal to this much per how much length? Meter length of the conductor. Then only this current is said to be 1 ampere. I hope it is clear. It is the constant current flowing through two thin straight parallel conductors separated by 1 meter produces a force of 2 into 10 raised to minus 7 Newton per meter. Between them is known as 1 ampere. I hope now it is clear. Now I will write the definition of ampere. Okay, so it is nothing but it is the constant current. It is the constant current. Which when maintained in a two straight thin and parallel conductors and placed placed at a distance of 1 meter apart in a vacuum. Okay, would produce between these conductors a force would produce between these conductors a force equal to 2 into 10 raised to minus 7 Newton per meter of length. Okay, actually here I am writing according to textbook definitions only. While you are writing theory examination, PU board examination, you have to follow the definitions, statements according to PUC textbook only. Don't write your own definitions. Don't use your own language. We want physics language only. Right? So it is the constant current I said to be 1 ampere, and it is a constant current flowing through these two thin parallel and straight conductors separated by a distance of 1 meter experiences a force of how much? 2 into 10 raised to minus 7 Newton per meter between the two conductors is known as 1 ampere. I hope it is clear. Right? The next one is plane angle. I think you already studied trigonometry. Plane angle. Okay? So what is plane angle? Do you remember plane angle? It is the angle subtended by an arc of a circle at its center is known as plane angle. Am I right? Now here I will write definition. Plane angle. Actually, plane angle is the fundamental supplementary physical quantity in a system. What is the SI unit of this fundamental physical quantity? Radian. Actually, I want to define radian. First, I want to define plane angle. Then I will define radian. Plane angle nothing but it is the angle subtended by an arc of a circle at its center is known as plane angle. Am I right? It is denoted by theta, plane angle. Okay, what is the SI unit? SI unit of plane angle. What is that? Radian. Right? We can represent like this. RAD. Now what is a radian? Radian is the plane angle subtended by length of an arc of a circle at its center is known as a plane angle. For example, if you consider arc of a circle, right? For example, right. Then it is the center of the circle. Yes. This is what arc of the circle. Center. O. Right? Then radius of the circle. R. Okay? This is nothing but L. Clear? This angle. Take it as r d theta. If it is d theta, we don't know d theta now, okay, leave it. Take it as theta. Theta is known as a plane angle. Am I right? Right? So it is the angle subtended by length of an arc at its center is known as a plane angle. Right? Then how to find theta? How to find theta? Right? Theta is equal to length of an arc divided by radius of the circle. Okay, then what is the length of an arc? Length of an arc is equal to L divided by R. Clear? This theta must be in radians only. Remember. Here we are measuring this theta in radians. Okay? Right. So theta must be measured in radians. So theta is equal to L by R. From this, we can write this like L is equal to length of an arc is equal to radius into theta. Dear students, remember this formula. In entire mechanics in first year, almost in mechanics, in everywhere we are using this relation. Please remember. But the condition is here, theta must be measured in radians only. Okay? Right. Then here, the next question is, for only this much length of an arc, the angle subtended by this length of an arc is theta. Then for complete circle, what is the total plane angle subtended by? Total angle subtended by for given circle, for complete circle, how much? For complete circle? For complete circle. How to find this theta? What is the formula? Length. For complete circle, what is the length? Length of the circle, nothing but circumference only. How much? This is how much? 2 pi r. 2 pi r divided by r. R gets cancelled. So for complete circle, this theta plane angle is 2 pi. What? 2 pi what? 2 pi. Remember, radians. Because of in trigonometry, we are also measuring theta in terms of degrees. But this is in terms of radians. 2 pi radians is equal to 2 pi radians is equal to how many degrees? 360 degrees. Correct? Pi radians. Is equal to how many degrees? 180 degrees. Please remember these two conversions, radians to degree. I hope it is clear. It is the angle subtended by length of an arc, of a circle at its center is known as a plane angle. If that plane angle is treated as a radian, then how to find this theta? Theta equal to length of an arc by radius of the circle. L is equal to r theta. Please remember this formula, very important in physics point of view. So plane angle nothing but it is the angle subtended by, otherwise you don't write length also, you just write subtended by an arc of a circle at its center is known as plane angle. It is denoted by theta. SI unit of theta, radians. Here theta, L is equal to r theta under theta must be in radians. So actually this is nothing but a 2D angle. Okay? Right? So for a given circle, if you consider arc of a circle, the angle subtended by this arc of a circle at its center is taken as theta. Clear? So this is about the plane angle. So based on our previous discussion, here I am assigning two questions. One is define Kelvin and another one is what is the SI unit of luminous intensity. Actually today we are not discussing candela definition. I know in next class after completion of solid angle I will explain candela definition. Wait. I hope today's class is clear.